Assalamualaikum and hello everyone. So today, me and my group are going to present our experiment, which is application of the first and second law of thermodynamics. Next. So here is my teammate, which is me, myself, Saefullah, Amin, and behind me, we have Hafiz Nur Izzuddin bin Jimat. And then next we have Yusup bin Omar, Muhammad Yusup bin Omar. And lastly, the one and only girl in our group, Lim Zi Hui. Next. So here we have a table of contents, which is contains of introduction. Second, we have objective. Next, we have a theory working principle. And then we have an experiment setup. Then we have methodology, safety procedures, result and discussion. And lastly, we have references. Next, I'm going to pass slide to the Hafiz Nur Izzuddin.
Hello, Assalamualaikum, and my name is Hafiz. Okay, let's look for introduction to this experiment. So, what is a thermodynamic? Thermodynamic is the study of energy and heat. The law of thermodynamics describes the relationship between matter and energy. The four laws of thermodynamics are zero law, first law, second law, and third law. So objective from the experiment is to apply first and second law of thermodynamics in various processes. Type of fluid used is limited to water, therefore the Cp value is the same. Temperature range from room temperature until 100 degrees Celsius. Mass of water used is limited to 0.1 kg for each hot and cool water. Time recorded temperature for both water is every 1 minute interval until it reaches equilibrium.
Okay,
I
so
will press
okay, thank you, Hafiz. So I'm Zi Hui, and in this experiment, we will only focus on the first law of thermodynamics and the second law of thermodynamics. So the first law of thermodynamics explains that the energy is conserved. Energy can change forms but is neither created nor destroyed. Moving to the next slide, we can see that this is one of the example. The sun will provide the heat energy, and the heat energy from sun is going to transfer as chemical energy and absorbed by plant for photosynthesis. The energy is not going to be destroyed because we are proven that plant can receive energy from the sun to carry out photosynthesis. Next. So the second example is the power plant. So we taking the coal into the boiler and then we heat it, and then the heat energy will boil the water inside the pipe, and then will change into the water will change into the steam and turn the steam turbine. The steam turbine, the mechanical energy will make the generator to turn the mechanical energy to electrical energy. Next. So this is proof that in the boiler we have heat energy, in the turbine we have mechanical energy, and in the generator we have electrical energy. So this is very clear that the energy inside the power plant doesn't destroy. Instead, they are actually transformed from heat energy to mechanical energy to another form, which is electrical energy. Next. So we're moving to this slide that explain on second law of thermodynamics. The second law of thermodynamics states that processes occur in a certain direction, not in just any direction. In this experiment, we are only focused on the heat energy. We believe that hot regions will pass its heat energy to the cold region. Next. So in physical process, in nature process, in a certain directions, not reverse direction, just one-way direction. For example, we can see the waterfall. The water flows down a waterfall. So without any work supplied to the waterfall, the water will not flows upward. Same goes to the cup of hot coffee here. So the hot coffee will not get hotter in a cooler room, meaning that the cool region will not transfer the heat energy to the hot region. Next. So this is our theory and working principle. So based on the conservation of energy principle, or the first law of thermodynamics is expressed as this formula, which is total energy enter the system minus total energy leaving the system is equals to the total change in the energy of the system. So in this experiment, we are consider hot water and cold water is our system, and the environment is the surrounding. So in this experiment, the energy in and energy out can be heat energy or work energy. But in this experiment, we assume that next. In this experiment, we only focus on the system. So we are not supplying any work towards the system. So work is equals to 0. And then we are assuming the system is adiabatic, which is we didn't supply any heat towards the system when the experiment is carrying on. So Q is equals to 0. So we focus on the system, the internal energy of the system. The hot water internal energy plus cold water of internal energy will equals to 0. And how to calculate the internal energy of hot water? We are taking the mass that multiplied by the specific heat capacity and multiply by the temperature change. We take the T2 is the final temperature and T1 is the initial temperature. We take the final minus the initial. So, okay. So in this experiment is considered as energy balance because in this system, the hot water will transfer the energy towards the cold water. So the amount of hot water transferring the energy is the same as the cold water will receive the energy. So they will achieve energy balance, meaning that energy balance is defined as the state achieved when the energy intake equals energy expenditure. Therefore, the expectation is the energy will achieve equilibrium in a system by transferring the energy within the system instead of destroy or getting other form of extra energy. Next. So according to Clause's statement, it is impossible for any system that the transfer of heat energy from cold to hot body without work. Therefore, we expected that the hot water temperature will decrease as the hot water is transferring the energy to cold water. So cold water temperature will increase. Okay, next. So I'll pass it to Hafiz to explain on experimental setup.
Okay, for this experiment, we have this picture of apparatus that we use in the experiment. Okay, Yusup, next. Okay, for the first apparatus, we have electric heater for heat the tap water to 100 degrees Celsius. Next, we have a glove to move the hot beaker to the cool water. And we have electric scale for measuring the weight of the tap water. Next, we have thermometer for measuring temperature. In this slide, we have measuring cylinder that used to measuring the tap water. And we have beaker for 100 ml and 500 ml. And next, we have retort stand to hold the thermometer at in the tap water. So I pass this discussion to Yusup.
Okay, thank you, Hafiz. So, I will explain about the methodology. The first step we need to consider is to prepare all the apparatus and set all the apparatus too. The second step is weight the mass of 0.1 kilogram of tap water. After that, pour that 0.1 kilogram of tap water into the small beaker. The fourth step is wet another 0.1 kilogram of tap water. Then again, put the tap water into the beaker. The fifth step is heated the small beaker until the water reach 100 degrees Celsius of boiling water. This is the maximum temperature that we use in this experiment. Use the thermometer to measure the temperature of the hot water. Sixth step, after that, we place the heated small beaker carefully into the beaker and measure the both hot water and tap water using two thermometers respectively. Then the last one is the both thermometer reading were recorded with time intervals using the stopwatch until both water reach the equilibrium. So I pass the safety procedure to Saefullah.
Thank you, Yusup. So here about we are going to talk about safety procedure, which is that we need to follow when we are in the lab. So here, the first we have a lab coat, which is we need to wear also in when we enter or when we do the experiment. Then we need to wear our shoes or safety shoes, which is we need to wear a proper PPE to make sure ourselves protected. Then next. So here the precautionary steps that we need to follow when we do the experiments. So first we have while reading the thermometer, our eyes should place perpendicular to the reading scale to avoid parallax error, which is we want to get the accurate value from the reading. And then we have stir the water using magnetic stirrer throughout the entire process to ensure even heating and cooling, which is to make sure the heat transfer that happened in the beaker got even heating and cooling. Next, we have the thermometer should not touch the sides of the base of the container, as the container might not have the same temperature as the solution. So we want the uh, reading from the temperature from the water, not the beaker. So we need to make sure the temperature was not touch the beaker. So we can get the value that we need, which is from the water, not from the beaker. Next, we have the beaker should not immediately be transferred to the cold water beaker once heating is done. This is to minimize the heat loss to the surrounding. So we want to reduce the heat loss from the experiment. So we need to make sure the hot beaker was transferred to the inside the cold beaker to make sure the heat loss from the experiment will be reduced. So we get the amount that we want from the calculation. Next. So this is a glove that we use in our experiment uh, when involve the hot beaker or hot water in the experiment. So we need to make sure that we use the glove when we touch the hot beaker, which is to prevent ourselves from harm. Next. So I will pass back the slide to the Yusup. Continue talk about the result.
Okay, this is the result that we consider in our experiment. So about the tablet data, we use the hot water temperature is until 100 degrees Celsius, which is the maximum temperature. And then the lower temperature is tap water with or cool water, which is 28 degrees Celsius. This is equivalent to standard room temperature. So the graph, we expect that the graph during the time interval, the hot water will decrease in temperature exponentially, while the cold water will increase in temperature. So the calculation, we calculate the energy change of hot water, then we calculate the energy change of the water, uh, so we can find the total energy change of uh, the system for the whole system. So we use the uh, equation of energy equal to mc theta delta. Theta delta is the changing in temperature. So about our discussion, the experiment is conducted to observe the first and second law of thermodynamics in various processes. Before the experiment started, the temperature of the hot water is 100 degrees Celsius and the cold water is 28 degrees Celsius. When the experiment carried out, the temperature of hot water will slowly decrease, and the temperature of cold water also increase until balls of water achieve the equilibrium temperature at the end of the experiment. The first law of thermodynamics states that the energy can only be transferred or changed from one form to another, which is in this experiment we can see that the heat energy from uh, how the from the hot water is transferred to the cold water until both water reach the equilibrium temperature. So discussion on our graph is the graph shows that the relationship between the time taken and the temperature of both hot water and cold water. Based on this graph, we can see that as the time taken increase, the temperature of hot water will decrease, but the temperature for cold water also increase until both of water finally have the same temperature. The hot water lost its energy to maintain its temperature, while the cold water gained the energy. Therefore, the increase in the temperature until at one point, both of hot water and cold water, the energy changing is equilibrium. The result from this experiment is agreed with the Clausius statement as well as the second law of thermodynamics. It was proved that heat water transfer from a high temperature body, which is the hot water, to the lower temperature body, which is the cold water, and also the surrounding. In other words, energy can only be transferred from the hot container to the cold container. But this cannot be done reversely unless there is work done in this experiment. So about the calculation, it was found that the change in energy both hot water and cold water was negative 21.318 kilojoule, which is not equal to zero. This is the first law of thermodynamics. The negative sign is illustrate that there was heat loss from the system to the surrounding during the experiment, in which not all energy from the hot water will transfer into the cold water. Then, in our discussion also, there are some possible errors that we considered. The first one, since this experiment conducted without any insulated material, so we expect that the heat will lost to the surrounding during this experiment. And the second possible errors during our experiment is our eyes cannot perpendicular to the scale reading while we taking the the, the temperature of the water by every 1 minute. So on our discussion also, we want to improve this experiment by make sure to prevent the heat loss to the surrounding. We need to use insulator material such as we suggest that cotton, because cotton is one of the best insulated material to maintain the temperature and to prevent the temperature loss to the surrounding. And then the second ways to improve our experiment, our eyes need to perpendicular to the scale reading during taking reading of the temperature. This is will prevent uh, any parallax error during the experiment. So this is the reference that we use in our experiment. So I think that's all from us. Thank you for watching.